Okay, so in this video we're going to be determining the discriminant. So what is the discriminant? The discriminant is this little bit here in our quadratic formula where I've got that b squared minus 4ac. And if I can figure out the value of that little section there, I can do a lot of assumptions before I even begin sketching a graph or looking what a graph might look like, in order to help me understand how it's going to turn out. So if we just take a look at these three examples I've got below, I've got three different equations. With all of them, I've done the initial step of using my quadratic formula where I've got it to that simplified form, and then I've got that final answer along with a sketch of how the graph looks. So let's take a look at that first one. In that first one, I end up with a discriminant of 4. And then when I put that in my calculator, I end up with my roots of 2 and 4. And now I can see my graph quite happily goes through the x-axis and I get these two roots. In my second example, I get 0 as my discriminant. And then I've only ended up with one answer here, the 3. And think about it this way. If I add or subtract the square root of 0, that's going to be 0 times 0. So add or subtract 0, not going to make a difference. So in this case, my graph only just hits the x-axis before it disappears up. So I've only got that one root happening. And in my last example, I've got a negative 4. Now currently, we can't square root a negative 4. So in fact, when I put that in the calculator, it would come up with an error. And that means I'm not going through the x-axis at any point. So I end up with this graph that's kind of hovering above. And so the key thing to focus on is for this first one, I have a positive discriminant, which resulted in 2 roots. In this one, my discriminant is 0, which resulted in 1 root. And in my last one, my discriminant is a negative, which results in no roots. And using that, we can help ourselves identify the nature of the roots. So here are some little statements. So when b squared minus 4ac is greater than 0, there are 2 real and distinct roots. Distinct means they are different. And when b squared minus 4ac equals 0, there is only one root. I wrote only one root. And when b squared minus 4ac is less than 0, there are no real roots. So using this, we are now going to try and find the nature of the roots for the following questions. So it's kind of like our quadratic formula. I still need to identify my a, my b, and my c. So in this case, a is 1, b is -1, c is -1. But then all I want to use is that little bit of my formula of the b squared minus 4ac. So I'm going to have -1 squared take away 4 times 1 times that -1. -1 squared is going to be a +1. -4 times 1 is going to be -4 times that -1, a +4. So I've ended up with 5. So I have here my b squared minus 4ac is greater than 0. So there are 2 real distinct roots. And I need that whole statement. I need to work out the value of b squared minus 4ac. I need to say that because it is bigger than 0, there are 2 real distinct roots. I need all that information for the mark. So let's take a look at another example. So here, a equals 1, B is -1, and C is 1. So using my formula of b squared minus 4ac, I'm going to have -1 squared minus 4 times 1 times 1. So that's going to be 1 take away 4, which is going to end up as -3. And then since b squared minus 4ac, in this case, is less than 0, there are no real roots. Okay, let's take a look at these two here then. So same idea. My A is 1, B is -2, and C is 1. So putting that in my formula of b squared minus 4ac, that's going to be -2 squared minus 4 times 1 times 1. -2 squared, that's 4. And then that's going to be 4. Just going to give me 0. So then since b squared minus 4ac equals 0, there is one real root. And then last example here, A is 2, B is -1, C is -3. So using my b squared minus 4ac, I'm going to have -1 squared minus 4 times 2 times -3. So that's going to be 1. Then -4 times 2 is -8. Times by -3, that's going to make a positive 24, which is going to be 25. So since b squared minus 4ac is greater than 0, there are two real and distinct roots. So that's all you need to do for these questions. Determine the discriminant, so evaluate it, and then once you know whether it's bigger, smaller, or the same as 0, then you can identify how many roots it has, if it has any roots. Let me know if you have any questions, and good luck with the work.